Okay, now standard 11, chapter number 8, Redox reactions, lecture number 5, which is a continue, in which we already discussed about stock notation, and now we switch on towards next your problem number 8.4, justify that reactions. This is a very important reaction, remember. First of all, if you don't know oxidation number, then you must know rules for oxidation number. Read or say so that particular lecture, and from that you identify how oxidation number is find out. So just to see, once again I repeat here, justify that reactions. Reaction is given 2 CuO solid plus 2 Cu2S. It gives 6 Cu solid plus SO2 gas. Here you have to find out which one is oxidation reaction, which one is a reduction reaction, which one is oxidizing agent or oxidant, and which one is a reducing agent or reductant. So first of all, write down once again this reaction. So here you see particular valency of this Cu2O, that means oxygen possesses -2, and therefore 2x minus 2 is equal to 0. So here oxidation number of copper is +1 and oxidation number of oxygen is -2. Remember this one. Next one, Cu2S and then once again S. So here also +1 and here also -2. So here you see 6 Cu solid, that means what? 6 Cu solid. So here 6 Cu solid, that is free state, therefore oxidation number is 0. And SO2, 2 2s are 4, x minus 4 is equal to 0. Therefore +4 and here -2. First of all, write down all oxidation number of element which is given in your reaction. So you have +1, here 0. Okay, and just you see -2 and here +4. So here, which one is oxidation reaction, which one is a reduction reaction, you have to identify from this particular. So here oxygen is -2, oxygen is -2, there is no change. Here +1, here also we can say that +1 to 0 once again. Here +1 to 0, +1 to 0. So we consider this +1 to 0. So what happened here? First of all, just you see -2 and here we can say -2 is cancelled out. But sulfur, just you see -2 to +4, -2 to +4, and copper is +1 to 0. यहाँ पे Cu2O which is converted into 6Cu and Cu2S which is converted to SO2 gas. So here oxygen is removed and here oxygen is added. You identify, you understand particular reaction, oxidation reaction, reduction reaction, and from that point of view, oxidation number +1 to 0. That means what? It is a decrease. 1 to 0 is decrease. So 2 minus 1. Okay? So here -1 is there, and just you see -2 to +4. Here oxidation number increase. -2 to +4 means how many it is increased? +6. So just you see, here -1 is there, here +6 is there. Minus means what? Minus means reduce, and reduce means nothing but reduction. And plus means what? Plus means it is an oxidation. Remember this one. So Cu2S, it gives SO2 gas. It is an oxidation reaction. So first answer is this. So this reaction is considered as oxidation reaction. +1 to 0. This reaction is considered as reduction reaction. And which one is oxidizing agent? So just you see, those under rows +1 to 0. That means here electron is added, and therefore this is a Cu2O is considered as oxidizing agent. And -2 to +4, here oxidation reaction occur, therefore it is considered as reducing agent. So according to your, we can say that particular question in text, Just I read that particular sentences. Just you see. Solution. Let us assign oxidation number to each. Then we therefore conclude that in this reaction copper is reduced from +1 state to 0 oxidation state. Okay, so this is considered reduction reaction. And oxidized -2 to sulfur is oxidized to -2 state to +4 state. -2 to +4. Therefore it is a oxidation reaction. Increasing oxidation number is known as oxidation reaction, and decreasing oxidation number is considered as reduction reaction. And therefore here answer is written. Further, CO2 helps sulfur in CO2s to increase its oxidation number. Therefore, Cu1 is an oxidant. Cu1 is considered as oxidant. This is considered as oxidant. Okay, and we can say that another sulfur of CO2s helps copper both in CO2s itself and CO2O to decrease its oxidation number. Therefore, sulfur of CO2s is reductant. This is considered as reductant. So here, oxidation reaction and reduction reaction, you have to understand this one. So which one is an oxidant and which one is a reductant? Just I write it. CO2s itself, that means Cu1 is an oxidant and sulfur of CO2s helps copper both in CO2s itself and CO2 to decrease its oxidation number. Therefore, sulfur of CO2s is reductant. It is given, and according to that, just you understand from oxidation reaction, reduction reaction, oxidizing agent and reducing agent. Practice for this reaction. H2 gas plus Cl2 gas, it gives twice HCl gas. So this is a practice from this particular problem. Here H2 gas plus Cl2 gas, it gives twice HCl. So here H2 is 0, Cl2 is 0, +1, -1, 0 to +1, and here 0 to -1. 0 to +1, oxidation number is increases, and therefore oxidation number increases. Therefore it is considered as reducing agent. Opposite yaad rakhna. 0 to -1 is considered as reduction, and therefore it is considered as oxidizing agent. So H2 gas is a reducing agent. Cl2 gas is considered as oxidizing agent. So therefore problem 8.4 and different types of another questions also over. Now next topic in your NCERT textbook is given, and different types of examples also given in your exercise. Just to find out, once again I repeat that particular answer of this question. First of all, write down reaction. Write down oxidation number of all the elements, and from that you have to write down which one oxidation number increases and in which one oxidation number decreases, change in oxidation number. So here find out first of all oxidation reaction, find out reduction reaction, and from that oxidizing agent, gaining of electron is considered as oxidizing agent, and losing of electron is considered as reducing agent. So here oxidant and reductant is also shown from this particular reactions. So here this topic is complete, and now switch on towards 8.3.1 types of redox reactions. Now 8.3.1 in your NCERT textbook, types of redox reactions. First is the combination reaction, second is the decomposition reaction, third is the displacement reaction, in which metal displacement, and second is a non-metal displacement reaction, and then fourth is a disproportionation reaction. This is a very important reactions which you have to learn it here, and might be learned in your lower standard also. So just to see, combination reaction means what? You know this one. Combination means combine, and they convert into product. Suppose A reactant and B reactant combine with each other and produce product C. So A and B reactant is there, and there is the one condition: A and B. From these both of A and B, one must be elemental form. One must be in elemental form or molecular form. So here you have to consider elemental form, and another is a maybe compound or say molecule. So here example is C solid plus O2 gas, it gives CO2 gas. So C solid means free state oxidation number is 0. O2 oxidation number in a free state is also 0. Here carbon is plus 4 and oxygen is minus 2. So this is also considered as redox reaction. Understand from this particular point, 0, 2 plus 4 oxidation number increases. So here which reaction is occur? Oxidation reaction. And 0, 2 minus 2. That means what? 0 to minus 2 means we consider decreasing oxidation number, and therefore it is considered as minus 2. And it is considered as 0 to plus 4 plus 4. So here minus 2 and here plus 4. So just O is 2, therefore minus 2 into 2, and therefore minus 4. Just we consider this in a half reaction and balancing redox reaction. At that time you understand particular thing, because here 0 is there, here minus 2 is there, but minus 2 of only one oxygen atom, but here 2 is given, so minus 2 into 2. So first of all you have to write down 0 to minus 2, first of all write down minus 2, and then multiply with 2, because it is balanced reaction, minus 2 plus into 2, therefore minus 4, and minus 4 that is nothing but here reduction reaction. So understand that particular point, and it is considered as combination. Carbon is reacts with oxygen and produce carbon dioxide gas. Same way, magnesium, just you see, magnesium metal is elemental form. In N2 gas, it is in a molecular form. So here, magnesium in a free state is considered as 0, and N2 in a free state is considered as 0. So oxidation number is 0. Here Mg3N2, therefore what happened? So just you see, Mg3, therefore Mg, whatever the charge of Mg is here, you have to consider one thing. So magnesium, whatever the oxidation number is, plus 2, and nitrogen minus 3. How? Just I explain it here. Mg3N2 is there. Suppose we don't know oxidation number of magnesium, then write down here 3 into X. Then plus 2 into oxidation number of nitrogen is here considered minus 3, and is equal to overall charge is 0. So 3x minus 6 is equal to 0. So 3x is equal to 6. So x is equal to 6 divided by 3. So x is equal to plus 2. Okay. So therefore magnesium is plus 2 and nitrogen is minus 3. Suppose you know oxidation number of magnesium. What is meaning of oxidation number? Once again I explain. Electronic configuration, if you know very well, then it is where is the magnesium Z is equal to 12, Ne, and then 3s2. So outermost orbital possesses 2 electrons, and therefore from 3s orbital 2 electron is removed. Where is it? So it's a plus 2. And nitrogen requires 3 electrons, because electronic configuration of nitrogen is nitrogen Z is equal to 7, He call 2s2, 2px2, 2py1, 2pz1. So here 3 electron is released from outermost orbital, and that's why it's considered as here minus 3. 3 electron is gained. Remember here, because it is a addition of electron. One is a losing electron, another is addition electron. So here nitrogen is a gain 3 electron, and 7 plus 3 is nothing but 10. You already know. And any core is considered as stable electronic configuration. Same example, CH4 plus O2 gas, it gives CO2 gas plus H2O. Here also this is also combination reaction. It is also considered as combustion reaction. Carbon, here carbon hydrogen, so minus 4, hydrogen is plus 1. Write down oxidation number immediately, because you already practiced for this. O2 gas is 0. CO2 once again plus 4, oxygen minus 2, hydrogen plus 1, oxygen minus 2. Those are common, do not consider it. Plus 1 is a common, so do not consider it. but just you see here O2 is there, so minus 4 to plus 4, minus 4 to plus 4, and here 0 to minus 2, and here also 0 to minus 2. Consider this reaction, and therefore one in which oxidation number increases, minus 4 to plus 4 in oxidation number increases, minus 4 to plus 4 oxidation number increases, and O2 we can say that oxidation number is decreases. So this is considered as, here N2 का ये 0 है, यहाँ पे oxidation reaction, and this is considered as 0 to minus 2 is considered as reduction reaction. Okay, so consider this one. It's a very easy example. O2 is going to minus 2 is also reduction reaction. Both reactions is considered as reduction reaction. In balancing redox reaction at a time we understood a particular thing, but here you have to remember this: one undergoes oxidation reaction, another undergoes reduction reaction. So here this is considered as combination reaction, in which product is obtained in terms of product and byproduct also. So here combination reaction is completed, and this is considered as redox reaction because oxidation reaction and reduction reactions occur simultaneously. Second thing, decomposition reaction. What is meaning of decomposition reaction? So here whatever the molecule is there, molecule must be in a, we can say, compound form, and this compound when we heat it at a time, we can say that different product is obtained, is considered as decomposition reaction. Suppose water, when we heat it, delta, that means heat more, and at times convert to H2 gas and O2 gas. This is considered as decomposition reaction because oxidation number of hydrogen is +1. First of all, you remember in any reaction you have to find out oxidation number. So it becomes very easy and identify certain which reaction is occur. Combination reaction, decomposition reaction at a time is very important. Oxygen is -2, hydrogen H2 gas 0, and O2 is considered also 0. So here +1 to 0, just you see, +1 to 0, and here -2 to, we consider 0. Both reaction is there. +1 to 0. Okay, +1 to 0 means what? It is decreased. So -1. So it's a minus is there. Therefore, it's considered as reduction reaction. Okay, this reaction is considered as reduction reaction. In O2 -2 to 0, it is an increase. -2 to 0, it is increased. That's what is considered as oxidation reaction. Okay, so ये बात है यहाँ पे. Twice NaH solid. Twice NaH solid. That means twice NaH solid plus H2 gas. Write down first of all oxidation number. +1. Hydrogen is in hydride form. Therefore -1. Oxidation number is according to rules of oxidation number. Sodium is 0 and H2 gas is also 0. So here +1 to 0, and here -1 to 0. +1 to 0 means what? +1 to 0. यहाँ पे +1 to 0. +1 to 0 indicate reduction. This is nothing but reduction reaction. Okay, and -1 to 0 is considered as oxidation. -1 to 0 is considered as oxidation. So therefore it is considered as decomposition reaction. It is also deals with, we can say, the types of, we can say, that redox reaction in terms of decomposition. Here NaH is decomposed in the form of metal as well as gaseous form. Here water is also converted in terms of two gaseous form. It is a very easy procedure. And this is nothing but electrolytic process, electrolysis process. And electrolysis, what happens? You have to take electrolytic apparatus, electrolyte apparatus. In this, you have to take tap water and put here anode and cathode, and anode and cathode. From that, if we add few drops of concentrated H2SO4, then on anode, dioxygen gas is released, and on cathode, dinitrogen gas is released. That you learn in later on in electrochemical cell and electrolytic cell. Okay, that you have to learn in standard 12 also, and standard 11 maybe. Last topic is also there at a time I explain. Next one is potassium chlorate. Potassium chlorate, when we decompose at a time, it's converted into twice KCl and 3O2. First of all, write down oxidation number. K plus 1, 3 to the 6, 6 plus 1, that is plus 5, oxygen minus 2. Here K plus 1, Cl minus 1 and O2 is 0. So here plus 1 is a common, do not consider it. But just you see here plus 5, 2 minus 1. Plus 5, 2, here minus 1. Plus 5, chlorine 2 minus 1. And therefore it is considered as which reaction? Oxidation number is decreases. 5, 2 minus 1. 5, 2 minus 1. Therefore it is a minus 6. And here minus 2 to 0. Minus 2 to 0. So here we can say that plus 5 to minus 1, it is a decrease, minus 6, and minus 2 to 0, it is considered as minus 2 and 0, it is increases, plus 2. Okay, so here oxygen undergoes oxidation reaction and chlorine undergoes which reaction? Plus 5 to minus 1, therefore reduction reaction. So here decomposition reactions is complete, but one example is also given. Calcium carbonate when decomposed at a time, it is converted into CaO solid and CO2 gaseous form. Plus 2 carbon, 3 to the 6 here. We can say that X plus 2 plus X minus 6 is equal to 0. So here X minus 4 is equal to 0. So here plus 4. Oxygen minus 2. Calcium oxide once again plus 2, oxygen minus 2, and here carbon is plus 4, oxygen minus 2. So here just you see calcium is not bad, but carbon and oxygen undergoes reduction and oxidation reaction. Maybe carbon and oxygen, just you see calcium is plus 2, carbon plus 4 to plus 4, and minus 2 to minus 2. There is a redox reaction or not? Calcium carbonate is converted into CaO solid and CO2 gas. This is a, we can say that it is a not decomposition. Decomposition reaction is there, but it is not redox reaction because both sides, just you see, whatever the oxidation number is there, it is a no change. Plus 2 to plus 2 in a calcium, there is no change. Plus 4 to plus 4, there is also no change. Okay, so here oxygen minus 2 to minus 2, so there is no change. So it is not considered as decomposition, we consider redox reaction. Redox reaction is decomposition reaction is there, but it is not redox reaction. In redox reaction, oxidation reaction and reduction reaction occur simultaneously. Just you see here in which oxidation number increases, in another we can say that oxidation number is decreases. Now displacement reaction. Displacement reaction is two types. You know this one already. X. Suppose one we can say that elemental is there and YZ is a one compound is there or molecule is there. It is just change the place. Here X is combined with Z, so XZ plus Y. So this is considered as, we can say that displacement. Just you see YZ is there, but this Y is displaced by X. So XZ plus Y. This is known as displacement reaction. In this displacement reaction, two types of displacement reaction, metal displacement and non-metal displacement. So first example is metal displacement. Just you see, CuSO4 gaseous. Okay, CuSO4, we can say that solid form, and ZnS, also aqueous form here, and ZnS solid form, it gives you solid plus ZnSO4 aqueous. Just you see here, CuSO4 and Zn solid is there. That means what? Here copper is in a free state, that means it is converted into Cu solid, and zinc is converted into ZnSO4. Once again we write down oxidation number. Here plus 2, sulfur plus 6, oxygen minus 2, here 0, copper 0, plus 2 plus 6 and minus 2. So just you see, plus 2 to 0 and 0 to plus 2, plus 2 to 0 and 0 to plus 2, plus 2 to 0 indicate what? Minus 2, and 0 to plus 2 indicate what? Plus 2, and this is nothing but oxidation reaction, and this is nothing but reduction reaction. So here what happened? Zn is we can say that copper is displaced by Zn. This reaction is considered as displacement reaction or substitution reaction. This is metal substitution reaction. That means here in CuSO4 aqueous, metal is copper, and here in free state metal is Zn. But in product side, just you see, copper is considered as a free state and ZnSO4 in a, we can say that converted in terms of compound. Another V2O5 solid plus 5Ca solid delta, it gives 2V solid plus 5CaO solid. Just you see, balancing of this particular reaction, Ca and O, therefore CaO, calcium oxide is there, and 2V, vanadium. So vanadium, oxidation number is plus 5, oxidation number is minus 2. In a free state, calcium is considered as 0, and 2 vanadium. Here oxidation number is considered as 0. In calcium oxide, calcium oxidation number plus 2 and oxygen oxidation number minus 2. Oxygen here you should see plus 5 to 0 and 0 to plus 2. So here vanadium is come in a free state in a product side, and calcium is produced, calcium or say calcium is converted into calcium oxide by gaining this particular oxygen. Then that means what? Adding with this oxygen. So vanadium is free. Therefore, it is considered as here V2O5 is there, but here 2V. That means vanadium is removed, and it's and 5CO is obtained. So one just you see plus 5 to 0. This is a reduction reaction. Minus 2. Just you see 0 to plus 2. It is considered as 0 to plus 2. Oxidation number increases, so it is considered as oxidation reaction, and plus 5 to 0, it is considered as which reaction? Reduction reaction. Same way, TiCl4 plus twice Mg solid, it gives Ti solid plus twice MgCl2, and in next one Cl2O3 solid plus twice Cl solid, it gives Cl2O3 solid plus twice Ci. What happens here? First of all, write down oxidation number in both this reaction. Plus 4, minus 1, 0, 0, plus 2, and here minus 1. So just you see, plus 4 to 0. Observe that titanium is going to plus 4 oxidation number to 0. That means what? Plus 4 to 0. First of all, find out which oxidation number is changed in which particular element or atoms. Plus 4 to 0. That means what? Minus 4. And 0 to plus 2, 0 to plus 2, it is indicated as plus 2. So here 1 undergoes minus means what? Remember, minus is reduce, and reduce is nothing but reduction reaction, plus 2 is nothing but oxidation reaction. So you have to consider this particular example. In Cr2O3 plus twice Cl solid, delta Al2O3 solid plus twice Cl solid. This type of reaction is given, and which type of reaction? It is a displacement reaction, combination reaction, decomposition reaction, or we can say that non-metal displacement or metal displacement. So just you see, aluminium and chromium both are metal. So here Al2, that means chromium, here aluminium take place of chromium, and therefore Al2O3 and twice Ci. Here chromium is displaced by aluminium. So here it's produced alumina, Al2O3 solid and twice Ci solid. First of all, just you see, write down oxidation number. So just you see here plus 3, here 0, here 0, here plus 3. That means what? Plus 3 to 0, plus 3 to 0, plus 3 to 0. It is decreased. Therefore, up to minus 3. That's why it is considered as which reaction? Reduction reaction. And 0 to plus 3. 0 to plus 3 indicate what? Plus 3. And therefore it is considered as which reaction? Oxidation reaction. Just we do not balance this particular reaction because here balancing of redox reaction is on in a particular next topic. But you first of all understand which one undergoes oxidation reaction, which one undergoes reduction reaction, which is an oxidating agent and which is a reducing agent. So this is a metal displacement. Now next topic is continuum B, which is considered as non-metal displacement, and then fourth is disproportionation reaction. Continue this topic and practice for this, and find out from this combination reaction, decomposition reaction and displacement reaction, just you find out which one is an oxidizing agent, which one is a reducing agent, which is undergoes oxidation reaction and which is undergoes reduction reaction. We continue this. Now chapter 8, Redox reaction, in which we continue with non-metal displacement. Non-metal displacement. So what is meaning of metal and what is meaning of non-metal? You know, are familiar with this one? In your NCERT textbook it is written the non-metal displacement redox reactions includes hydrogen displacement and a rarely occurring reaction involving oxygen displacement. Now see, here I give certain examples. First of all, just all alkali metals, that means first of all we consider alkali metals. Alkali metals. In which example is given that twice Na solid plus H2O, it gives twice Na OH aqueous plus H2 here in a gaseous form. So this is the alkali metals. You know, this sodium metal is alkali and here is a metal form and here is a H plus is considered as non-metals. So just you see, H2 gas is converted and therefore it is considered as non-metal displacement. Here hydrogen and oxygen. Here oxygen is replaced by we consider Na and OH and here it produces H2 gas. So first of all, write down oxidation number. Na free state 0, H2 here plus 1, oxygen minus 2, Na plus 1, oxygen minus 2, hydrogen plus 1 and H2 gaseous form 0. Now change in oxidation number 0 plus 1, Na to Na plus, and here twice H2 is there, that means it is 0. Here plus 1 is converted into 0. So there is a change in oxidation number 0 to plus 1. So here plus 1 indicate what? Which reaction is there? Oxidation reaction. And next one is plus 1 to 0. Plus 1 to 0. Plus 1 to 0. 1 to 0 means what? 1, 0. It is reduced. So it is considered as minus 1 and therefore it is considered as reduction reaction. So here, just you see, alkali metal is in free form and here it is converted into alkali ions. That is Na solid in a free state and here Na plus is converted in terms of ions. Here in water twice H plus is converted into H2 gas and therefore oxidation reaction and reduction reaction takes place. So we can say that alkali metal is replaced by H plus. Okay, so here alkali metal we can say that here it is reacts with H plus is converted to H2 gas and Na solid is converted into Na plus. Suppose you know we can say that ionization form, then it becomes very easy. Twice Na solid plus H2O means what? Twice H plus aqueous form plus twice OH minus aqueous form, it gives twice Na plus aqueous plus twice OH minus aqueous plus H2 gas. Just you see, twice OH minus, both side cancel out. So twice Na solid plus twice H plus aqueous, it gives twice Na plus aqueous or say plus H2 here. This is formed. Suppose we write oxidation number at here. Sodium oxidation number is 0. Oxidation number of this hydrogen is plus 1. Do not consider this one. Here oxidation number is plus 1 and here H2 free state, therefore is a 0. So 0 to plus 1, that means it undergoes oxidation reaction, and plus 1 to 0, that means what? It undergoes reduction reaction. Here Na0 converted to plus 1, so 0 to plus 1 means plus 1, it is increased up to plus 1, and therefore it is considered as oxidation reaction. H plus 1 to 0, 1 to 0, that means decrease in oxidation number, so it is a minus 1, and therefore here just you see, multiply with 2 and here also multiply with 2. Okay, so that's way, first of all, if you write, then this reaction undergoes oxidation reaction and reduction reaction. Here alkali metal is displaced by, we can say that OH, we can say water molecule. So alkali metal is we converted in terms of Na plus ion, alkali ions. So this is considered as non-metal displacement. Okay, now next reaction, just we continue. Suppose I write one reaction. Try to solve yourself, which is given in your textbook. CH twice aqueous, this reaction is given. Okay, this thing is given. Find out oxidation reaction, reduction reaction, which type of reaction is there. Here calcium is considered as alkaline earth metal. You know this one, this is alkali metal, this is considered as alkaline earth metal. So here calcium twice H2 increase CH twice plus H2. This is for alkaline earth metal group 2. In the periodic table, this is considered as group 1. So this is in your homework. Find out. We can say that how we can say that it is a non-metal displacement reaction. Just you try yourself. Next one, instead of calcium, Mg solid plus 2H2O liquid. It gives Mg OH twice aqueous plus H2 gas. This is in your homework. How you can say that it is a non-metal displacement reaction. Non-metal displacement reaction because H plus is replaced by Mg. So here it is considered as non-metal displacement. Remember this one. Another example is given: Zn plus HCl, Mg plus HCl, and Fe plus HCl that we take later on. But practice for this. Okay, do practice for this particular reaction and find out oxidation reaction and reduction reaction with the help of oxidation number. Continue with our next we consider a particular reaction. That means what particular Zn, zinc, then magnesium, and then we can say that Fe. Where reacts with HCl? Zn plus Zn solid plus HCl aqueous form. Actually, zinc acts as a metal and chlorine acts as a non-metal. So here, product obtained as ZnCl2 aqueous form plus H2 gaseous form. So this reaction is there. Another is magnesium solid. Just you see, Zn solid plus HCl, it gives ZnCl2 plus H2 gas. What is our topic? Non-metal displacement. So here chlorine is displaced by, we consider Zn. So Cl minus is ZnCl2 and here H2 gas. Okay, so it is considered as non-metals. So here just you see, many metals including those which do not react with cold water are capable of displacing hydrogen from acids. So here we take example of acids. Dihydrogen from acids may even be produced by such metals which do not react with steam. Calcium and tin are the example of such metals. If you example for the displacement of hydrogen from acids are Zn solid plus HCl gas aqueous, it gives ZnCl2 aqueous plus H2 gaseous form. H2S not but H2 in a gaseous form. Write down this way. So here another example is simple, and from that just you see oxidation number of Zn is 0, plus 1, minus 1, here plus 2, minus 1, and here 0. So just you see 0 to plus 2. 0 to plus 2, and here minus 1 2, just you see minus 1 to minus 1, it's cancelled out. So here plus 1 to 0. When it is changed, you have to write that oxidation number. Those are not changed, you just remove it, don't bother about that. So here 0 to plus 2 indicate what? Oxidation reaction. And plus 1 to 0 indicate what? Reduction reaction. Okay? So it's reduced. We can say that H plus is converted to H2 gas by gaining electron, and Zn we can say that produces Zn plus 2 by, we can say that losing electron. So here it is reaction with Zn. Same way you write down for Mg and Fe. Here you have to balance with respect to Zn is there, Cl is there, 2, therefore you write down here 2. Same way another reaction, you try yourself, Mg solid plus twice HCl aqueous, it gives MgCl2 aqueous plus H2 gas. And same way Fe solid plus HCl, here twice HCl, that means it is converted into FeCl2, aqueous plus H2 gaseous form. So this way particular reactions you remember. And another reaction is also given that particular order is also there in section. Just you see, in reactions, particular these reactions are used to prepare dihydrogen gas. You know this one. When metal is reacts with acid, it produces dihydrogen gas. You already know this one. And from that we can say that H plus is reduced to H2 gas. And that's why this particular reaction HCl, H plus is going to H2 gas with gaining electrons. So it's a reduction reaction, and this one is an oxidation reaction. So from that point of view to remember. Another is, we can say that particular example, twice H2O liquid plus F2. Here one example is given. F2 in a gaseous form, it gives which product is obtained here? HF, hydrogen fluoride, which is in aqueous, and here O2 gaseous form. So first of all, write down here oxidation number. Here oxidation number of hydrogen is +1, oxygen is -2, free state F2 gaseous form is 0, hydrogen +1, fluorine -1, and O2 in a free state considered as 0. Okay, so here we can say that oxygen is removed. Just you see, one example is very important. Here, due to, we can say that electronegativity of fluorine is more as compared to oxygen. So here, non-metal is there. Oxygen is non-metal. Here, fluorine is, we can say that displaced. So HF is produced and H2 gas is, we can say that released. So from that we can particular say which one undergoes oxidation reaction and which one undergoes reaction. 0 and here -1, balance with respect to 2F2. O2 is complete, O2, okay, fine. Balancing is very important. 0 to -1 and -2 to 0. Okay, so here 0 to -1. 0 to -1 indicate what? Reduction reaction. What is reason? 0 to -1, reduce. And here -2 to 0 indicate what? Oxidation reaction. Perfectly written down. Plus and then oxidation reaction. Okay, so this is undergoes oxidation reaction, this is undergoes reduction reaction. Remember, oxidation reaction is considered as oxidation reaction. H2 is going to O2. We can say that electron is gained or lost. Here, electron is lost. So, electron is lost is nothing but reducing agent. And 0 to -1 is reduction reaction in which gaining of electron when converted into F- ion. That's why it is considered as oxidizing agent. And you already know that fluorine is a oxidizing agent according to EMF series. So this much topic is including at here. And one thing is given. It is for this reason displacement reaction of chlorine, bromine and iodine using fluorine are not generally carried out in aqueous solution. On the other hand, chlorine can displace bromide and iodide ions in aqueous solution as shown below. That means reaction is given Cl2 gas plus twice KBr aqueous, it gives twice KCl aqueous plus Br2 in a liquid form. And another is Cl2 gaseous plus twice Ki, same way twice KCl plus I2. And another whatever the reactions are there we discuss later on. Just to note down this. Okay, now next reaction in your NCERT textbook is given. Just I write it. Cl2 gas plus twice Br minus aqueous. It gives twice Cl minus aqueous plus Br2 in terms of liquid. Here, another is example also there. Cl2 gas plus twice I minus aqueous is converted into once again twice Cl minus aqueous plus I2 in terms of solid. So here, just see. How we can say that which one undergoes oxidation reaction and which one undergoes reduction reaction? And this is considered as non-metal displacement. the displacement. So here oxidation number of CL2 is 0. Here bromine considered as -1, chlorine is also -1, and Br2 is also 0. Okay. This one is carried out by me and this one is in homework. So just you see which one undergoes oxidation reaction, which one undergoes reduction reaction. So 0 to -1 is there. 0 to -1. That means what? 0 to -1. It indicates that it is a -1. So it's a reduction reaction. And -1 to 0. -1 to 0 indicate what? +1. And this is nothing but oxidation reaction. So here Cl2 is reduces to Cl minus and Br minus is oxidized to Br2. You understood this one or not? So which one is oxidizing agent and which one is reducing agent from this? Cl2 gas, and why Br minus is there? It's gaining electron, and that's why this reduction reaction containing Cl2 gas is considered as oxidizing agent, and 2Br minus is considered as reducing agent. Is it clear? Those are losing electron, they are considered as reducing agent. Those are gaining electron, they are considered as oxidizing agent. So this one in for homework. Just to try yourself which one undergoes oxidation reaction, which one undergoes reduction reaction, and which is oxidizing agent and which is reducing agent. Now next example is given in your textbook that Br2 liquid, same plus twice I minus aqueous. It gives twice Br minus aqueous plus I2 in terms of sound. Just to see once again, write down first of all oxidation number. So Br2, bromine is there, I minus, iodide containing solution is there, bromine is a non-metal, so Br2 0. Here I is considered as -1, here also -1, and here 0. So 0 to -1 and -1 to 0. Br and Br. So here 0 to -1 indicate what? Reduction reaction. -1 is 0. And therefore it is considered as reduction reaction. So it is act as oxidizing agent. And -1 to 0. -1 to 0 means what? +1. And this is considered as oxidation reaction. Is it clear? So here sentence is given that halogen displacement is there, because here you see chlorine, iodine, chlorine, bromine, Br minus, Br2 and I minus, they are from halogen group, and the halogen compound is there. The halogen displacement reactions have a direct industrial application. Remember, the recovery of halogen from their halides requires an oxidation process. Remember, which process is there? Oxidation process, which is represented by any reaction. Suppose we consider twice X, and here we write down X. It is converted into X2 plus 2 electron. Is it clear? And this is nothing but losing of electron. That's why it is known as oxidation reaction. Okay. And another example in your NCERT textbook is not given. Fluorine is also there. So this way you have to understood non-metal displacement. And another example you consider in a homework. Now we switch on towards most important reaction in next session, that means in continuing lecture, disproportionation reaction. Okay, the next topic is disproportionation. So very important. Reaction. Generally what happened in redox reaction, particular one element undergoes oxidation reaction, another we can say undergoes reduction reaction. But in particular in a special case, this proportionation reaction, we can say that one element undergoes oxidation reaction as well as reduction reaction. Understood this one? One element is converted into, we can say that, oxidized, and they are reduced also. So this type of reaction is considered as disproportionation reaction. So here we can say that it is a special type of redox reaction. In a disproportion reaction, an element in one oxidation state is simultaneously oxidized and reduced. One of the reacting substance in a disproportionate reaction always contains an element that can exist in at least 3 oxidation states. First of all, we take example of this one, so it becomes very easy for you. H2O2. Suppose we take hydrogen peroxide. One example is very simple. H2O2 aqueous is converted into twice H2O, and here liquid plus this is formed. So here twice H2O2 aqueous, it gives twice H2O liquid plus O2 gaseous form. What is our first we complete oxidation number of elements. Hydrogen plus 1, oxygen special case minus 1. Remember this one, it's very important. Hydrogen plus 1, oxygen here minus 2, and oxygen here 0. Oxidation number just you see. Plus 1, there is no problem, but just you see. Minus 1 is there. They are converted into minus 2 as well as 0. Because here in H2O oxygen atom is there, in O2 oxygen atom is there, but O2 contains free state, so it's a 0, and here oxygen minus 2, because you know this, it's oxide O minus 2 is there. But minus 1 to minus 2, minus 1 to minus 2, that means what? Minus 1, okay? And another, same way, same element is there, minus 1 to 0. Once again just you see plus. So this is nothing but reduction reaction. This is nothing but, you can say that, oxidation reaction. So just you see H2O2, one compound is there. In particular we can say that oxygen, one element is there. They are converted into 2 oxidation states, that is minus 2 as well as here 0. Because in water molecule, oxidation number of oxygen is minus 2, and free state O2 gas, oxidation number is 0. And that's why minus 1 here reduced to minus 2. So it's a reduction reaction, minus 1 oxidized to 0. We can say that oxidation reaction. So this type of reaction is considered as disproportionation reaction. Is it clear? But you understand from this particular point of view. Here oxygen is there, minus 1 to minus 2, and here minus 1 is converted to 0, and that's why it is considered as, we can say that, disproportionation reaction. Next example is also given. First of all, whatever the reaction is given, any reaction is given, write down first of all oxidation number, and from that point of view, find out which one undergoes oxidation reaction, which one undergoes reduction reaction. And suppose one element from the compound, they are oxidized and reduced, that means it is a disproportionation reaction. You have to remember this. Okay, now P4 solid plus next one is 3OH minus aqueous plus this reaction is given to you 3H2. It gives PH3, and the next one is PH3, that is phosphine gas, plus H3PO3, phosphorus acid. H3PO3 is nothing but phosphorus acid. So first of all, write down oxidation number P4. that is we can say that 0. Oxygen minus 2, hydrogen plus 1. Here H2O plus 1, oxygen minus 2. Here P, hydrate form is there, so plus 1 is there. Suppose hydrogen plus 1, so here minus 3 and here plus 1. Same way, find out here oxidation number of phosphorus. So 3 into plus 1 plus X plus 3 into minus 2, total charge is 0. So plus 3 plus X minus 6 is equal to 0. So X minus 3 is equal to 0. So X is equal to plus 3. Here hydrogen plus 1 and oxygen minus 2. So just to see, in P4 molecule, okay, converted into here minus 3 and here plus 3. And therefore, one element is there which is converting particular just in oxidation reaction and reduction reaction. 0 to minus 3. First of all, this is considered as reduction reaction because oxidation number, change in oxidation number is decreases. Same way, 0 to plus 3, it is an oxidation. And that is nothing but disproportionation reaction. Okay? Just you see, phosphorus is there. Here also phosphorus, and here also phosphorus. Therefore, it is considered as disproportionation reaction. P4 oxidation number is 0. Here in PS3, what is in PS3? It's a phosphine minus 3, and H3PO3, that is considered as phosphorus acid. So plus 3. So 0 to minus 3 and 0 to plus 3. Which one is reduction? Which one is oxidation? One element undergoes oxidation reaction. Same we can say that undergoes reduction reaction, and that's why it is considered as disproportionation reaction. Just to see another example in your textbook and solve it. Okay, so this topic is now completed. Disproportionation reaction. So just to learn which particular reaction. First, combination reaction. Second is displacement reaction. Okay. Third is, we can say that first is combination, second is decomposition, third is displacement, in which metal displacement and then non-metal displacement, and fourth is disproportionation reaction. So here many questions asked, maybe reaction is given and which type of reaction is there. Give example of displacement reaction, give example of non-metal displacement reaction. This type of question may be asked. So be ready with a particular one reaction. Okay, how we can say that disproportionation reaction is a very important standard 12 also. So this is nothing but we can say that disproportionation reaction. Okay, now this particular topic, so lecture number 5 is completed, and now we switch towards we can say that exam problems in the next lecture, and then balancing of oxidation. We can say that redox reaction. Okay.